So now we have a problem where we have cotangent alpha equals negative 4 over 3 and sine alpha is negative. We need to find cosine and cosecant. Now thinking back to the trig identities that I do have, I know off the top that I can relate cotangent and cosecant. I know that cotangent alpha plus 1 is equal to cosecant alpha. And of course this is a Pythagorean identity, so these have to be squared. So let's square them. We already have it solved for cosecant squared alpha. So cotangent squared alpha, I will have to square the 4 over 3, which will become 16 over 9. And then that's plus 1. I have to change the 1 into 9 over 9. So 16 plus 9 is 25. I have 25 over 9 equals cosecant squared. And then once I square root these, I get my answer, which is 5 over 3 equals cosecant alpha. So that's cosecant. In order to find cosine, the easiest thing for me to do would be to find sine and use the Pythagorean identity, or I can find sine and use the basic identity for cotangent. So either way I need sine, so I'm going to use that, flip it, 3 over 5 equals sine alpha, and now I can use sine. The easiest identity, if I can use it, will be the basic identity. So the basic identity says cotangent is equal to cosine over sine. If I'm trying to find cosine, I just need to multiply both sides by sine. So cotangent is negative 4 over 3 times sine, which is negative 3 over 5. And once we multiply straight across, 4 times 3 is 12. Or actually, we can cancel the 3's. So let's erase that 12. So we end up with 4 over 5. Now let's double check whether we are positive or negative. It says that sine is negative and cotangent is negative. So if you go back and do your all students take calculus, since cotangent is negative, it's either going to be in the second or fourth quadrant. And since sine is negative, it's going to be in the third or fourth quadrant. So we are in the fourth quadrant where cosecant is negative and where cosine is positive. And that is the end. Alright, now on number 6, you can notice that both of those are squared. And if you have those identities memorized, you'll know that tan squared and secant squared are related in the Pythagorean identity. Pythagorean identity says that tan squared theta plus 1 is equal to secant squared theta. And if I subtract tan squared theta on both sides, I get 1 equals secant squared theta minus tan squared theta. Now, no matter what theta is, as long as it's the same angle in both of them, if I have secant squared of something minus tan squared of something, it's going to be equal to 1. So the answer to number 6 is just 1. Let's look at number 7. Number 7, we have tan 40 minus sine 40 over cosine 40. I know that sine over cosine of an angle is equal to tan, so I can rewrite this as tan 40. And so I end up with tan 40 minus tan 40, which is equal to 0. Number 8 is already set up exactly like the Pythagorean identity. If I have sine squared of an angle plus cosine squared of the same angle, those two added together will be 1. Same thing for number 9, 1. Alright, here we have another problem where they give us a trig ratio, and we're supposed to use trig identities to find cosine and tangent. The first one will be used to find your values, and the second bit of information will help you find out which quadrant it is so you know whether it's positive or negative. Secant is related to cosine. How is it related? Well, they're reciprocals of each other. So all I have to do is flip that and I have cosine. Cosine alpha is going to be equal to negative 1/4. The end. I don't really have to try to figure out which quadrant it's in to know if it's positive or negative, because if secant is negative, cosine is a reciprocal, it's also going to be negative. Now I need to find tan. Well, I know that according to our trig identities, tan and secant are related. So I know that tan squared alpha plus 1 is going to be equal to secant squared alpha. And if I subtract 1 on both sides, I end up with tan squared alpha equals secant squared alpha minus 1. So let's go ahead and put in what secant squared alpha is. Negative 4 squared. So that's 16 minus 1, which is 15. And we're going to square root both sides. And so we have tan alpha is equal to the square root of 15. And we're just going to leave it like that because we can't simplify it. Now, I took the square root of something, so it could be positive, it could be negative. We need to know which quadrant we're in to determine whether it's positive or negative. All students take calculus. If secant is negative, that means cosine is negative. That means I'm either in the second or the third quadrant, and then it says cosecant is positive, meaning sine is positive. So I'm either in the first or second quadrant, which means we're in the second quadrant. Since we're in the second quadrant, tan will be negative. We're going to use the reciprocal identities to find the exact value of the rest of the trig functions. They gave us sine and cosine, which makes it very easy on us because the reciprocals you just need to flip, and tan you just need to divide. So let's find tan first and then find all the reciprocals. Tan theta is going to be equal to sine over cosine. So that's root 5 over 5 divided by root 2 over 2 divided by 5. Since we have the same denominator in both, we can go ahead and cancel. And we have tan theta is equal to root 5 over 2. Now let's get the reciprocals. We just need to flip. So cosecant is going to be equal to 5 over root 5, which is equal to 5 root 5 over 5, which if I cancel that down is just root 5. Secant, if I flip that, it's 5 over 2 root 2, which is equal to 5 root 2 over 2 times 2 is 4. And that's that. And then for cotangent, we just need to flip tangent. It'll be 2 over root 5, which is equal to 2 root 5 over 5. And that's that. For B, we have sine is negative 1/3, and cosine is positive 2 root 2 over 3. So let's go ahead and get tan. Tan will be sine of cosine, so it's negative 1/3 divided by 2 root 2 over 3. The numbers are the same, they cancel out. So I end up with negative 1 over 2 root 3. We have to rationalize it, so that becomes negative root 2 over 4. So let's get our reciprocals. Reciprocal of 1/3 for cosecant is 3. So that's negative 3. For secant, we're getting the reciprocal of 2 root 2 over 3, which is 3 over 2 root 2, which is equal to 3 root 2 over 4. And then we have cotangent, which is the reciprocal of tangent. It's going to be 4 over root 2, and that's negative. So that's going to be equal to negative 4 root 2 over 2, and then the 4 and the 2 reduce to give you negative 2 root 2. Remember that we are using odd and even identities to find exact value. Remember that cosine is the only even function, cosine and secant. The rest are going to be odd. So with cosine, we can just get rid of that negative on the x. But for the rest of them, we need to bring that negative to the outside because they're odd. So if cosine x equals 0.5, then cosine negative x is the same as cosine x, which will also be 0.5. If sine x is 0.15, then sine negative x is, well, we just need to bring that negative to the outside, and it's negative of whatever sine x is. Sine x is 0.15, so that's 0.15. Here, this one's tricky. Tan x, regular tan x, is equal to negative 3. So when we bring that negative to the outside, we get negative 3, which is positive 3. So you can kind of think of it as with the odd functions. If you're taking an odd function of negative x, you're going to change the sign. With an even function, you're not going to change the sign. Secant, which is a reciprocal of cosine, is an even function, so we're not going to change anything. Secant of negative x is the same thing as secant of x, which is 1.4. Alright, so the rest of these we have to go to the unit circle.